Today, we are going to release the ZG05HV series. So that is a brand new NPI we're giving you a sneak peek that will be released to the distribution channel here very shortly. So that's great. I want to say as a daily reminder, don't forget you can throw your questions into the chat. We do pay attention on the chat as it's going along, so don't be afraid to drop those in, and we'll get those in front of the presenters. But don't forget about our friendly poll questions. So as those pop out through the presentation, please take a moment to complete the poll questions. Today we have two presenters. We have Naral, who's going to walk us through that NPI release of the ZG05HV. And then we also have Dave Gallagher, who's going to walk us through a refresh on the K.FL2 and the FH82. So something a little special about the FH82. So without further delay, I'm going to pass it over to the product experts, and they can take it away. So thanks again for everyone for attending, and away we go. Naral, it's all you.
Hello. Good afternoon, everyone. My name is Naral Rapid. I'm a field application engineer for the Midwest Territories. So I'm thrilled to announce our brand new product, the ZG05HV. This is a high voltage 3.3 millimeter pitch wire to board connector rated at 1,000 volts and 1 amp per pin. So let's dive into it. So here's a product breakdown of the full assembly. So basically, you have the female contacts that go on the cable side. Then you have the plug housing plus a retainer. Retainer, what it essentially does, it gives you a higher cable strength, retention force on the cable side. And then you have the receptacle with through-hole reflow retention tabs to give you a higher peeling strength. And then the male contacts are inside the receptacles. And this is what makes the full assembly of the ZG05HV connector. So moving on to the connector design for this product. So the housing for this connector has protruding walls that separate adjacent contacts, thus increasing the creepage distance between each contact. So increasing the creepage distance enables the higher voltage rating and the higher withstanding rating. And this gives you a compact size for a high voltage connector. So let's put the first question in our poll. Where are the male contacts located? Is it in the plug housing, receptacle, or on the cable? We got 10 response and we got 69 people in this meeting. So all right, let's move on to the next slide. So let's move on to the design, the electrical shock prevention design. So essentially, since this is a high voltage connector, you don't want people putting their fingers in and touching the male pins, because if you do that, you got 1,000+ voltage running through your body and you might just end up like a fried fish. So to prevent this, this connector is IP2X rated. This means that it's designed in a way so you don't accidentally insert your finger and have those 1,000 volts going through your body. So it is finger-proof IP2X. Moving on to our next slide, the contact design. So this connector is suitable for high vibration environments. This is due to the combination of the double layered spring design plus the 3-point contact design. Let's see, let me get my laser out. So right here, this is the double spring layer design where you have the 2 springs pushing, having force pushing up on the male pin. And then you have the 3-point contact design. The 3-point contact design has 2 embossments and spring contact. Essentially, the 2 embossments and the spring contacts hold the male pin firmly, while the double layer spring design increases the contact force on the male pin to counteract any external vibration. This results in a robust connection point under extreme vibration. So if you have applications where vibration is seen, high vibrating environments, this connector is perfectly suitable for those type of environments. Plus, not only that it's high voltage rating and fingerproofing and high vibration, but this has also got mating keys available as well. There are 2 keying options currently. There's a standard black key, as you see right here, and then there is an orange key. This is called the A key. These 2 keys prevent any mismating when multiple connectors are used on the same board. Moving on to our question 2. This product has 3 points of contact, 4 points of contact, or 2 points of contact. Let's see. All right, we got more responses on question 2 than question 1. Let's go. All right, we'll move on to the next slide. So comparing our product to competitors' product. So a conventional product has a higher pitch. It's got a 5.4 millimeter pitch, and our product has a 3.3 millimeter pitch. So essentially, having those protruding sidewalls that separate adjacent contacts from each other, increasing that pre-pitch distance that prevents any arcing or short circuiting, that is what makes our connector more compact and lowers the width of the connector compared to a conventional product. As you see, a conventional product is 5.4 millimeter pitch, a width of 33.7 millimeters. Compared to the ZG05HV, you have a height or a width of 25.4 millimeters. So essentially saving you a lot more space. Second. It's not moving. All right, moving on to the heat resistance. So the heat resistance comes from a thermal shock. I'm showing you guys some thermal shock data. The testing conditions for this test were going from -40°C to 125°C in a span of 30 minutes. And once this is done, once you go from -40 to 125 in 30 minutes, that's 1 cycle. So when we're comparing the ZG05HV connector to our competitor products, our contact resistance stays stable for up to 3,000 cycles. And as you see in our competitor's product, you can see an increase in contact resistance around 125 cycles. So if we're presenting this to a customer, we can show them this data saying how reliable a connector is under high temp for a long time. Moving on to the tools and specifications. So the tools, applicator, and hand tools are available on our website, and you can get these part numbers on our catalog. There's also a retainer releasing tool to release the retainer and a contact remover tool available as well. And the performance characteristic, it says that there's 1 amp per pin power, or 1 amp per pin for all pins, and 1,000 volts -40 to 125 C with a withstanding voltage of 3000 volts AC. We're on to the part number structure. So the part number structure, you have the series name and then you have the position counts. Currently, this connector is only in mass production for 6 positions and 10 positions are under planning. So if you are showing these connectors to your customers, just please make sure you have that in mind. Plus, you have at number 6, you have the 2 keying options available. If there's nothing, that's just the standard black key. And if you want the A key, the orange key, just make sure you have that parentheses A to give you that A key option. Plus, the crimping contacts are good for 22 to 24 wire gauge. Moving on to the application example. So we saw this connector. Now, where does this connector go into? Essentially, this connector can go into any electric vehicles or any vehicles where ECU battery onboard chargers are there, plus battery storage modules, any battery management systems, battery storage modules where high voltage is needed. You can show this to your customer and get that feedback. Maybe they're using current wire to board connector that's too big, and after showing this connector, they might like that small compact size with the protruding walls. Another area that it's popular in is medical applications, especially CT machines. With CT machines, you usually have a power supply that gets connected to all the different detectors in the gantry, different sensors and different detectors. So going from that gantry out, you're using a wire to board connector. So the ZG05HB connectors could be a good use for customers that are making CT machines. Moving on to our last and final question. What is the applicable wire gauge range? Is it 10 or 18 to 20, 20 to 24, or 24 to 26? It looks like the answer is pretty good for this one, 100%.
But how many answered it in a row?
I think 10.
Oh, okay.
We got, okay, we got more coming, a lot more coming. Good, it's good. All right, we got a good amount now. Okay. So thank you guys. That was my presentation, and now I'll be giving it to my good sir, Dave Gallagher.
There was a question in the chat box there talking about competitors. I thought I saw. Do we have any specific competitors that we identify? I know we kept it generic on the competition on this one. Do we have a specific connector, do you know, of that was competition on this one?
I have to look into that, but I can follow up with you after. I'll put the answer in the chat. But yeah, we were just looking at a number of general companies that have 1000-volt rated wire to board connectors and just comparing them all.
Yeah, in general, usually when you have a high voltage connector, the pitch is much higher, and that really contributes to the size of the connector in general. So across the board, if you were to look at connectors that have a high voltage, you're usually going to see a much larger physical size, and that's really the big advantage that we have on this product series, is that physical product is so much smaller in comparison to our competition. But we'll get a little bit more details at and share that out at a later time. Great question. Slides load up here, and we'll get going here. All right, as Scott mentioned at the very beginning, the first series they're going to be covering is the K.FL2 series. And for most of you, you're familiar with things like our U.FL series, and you're familiar with our maybe X.FL series, really small connector. This connector, the K.FL2, kind of falls in the middle of those categories of size. So it's really about physical size when you're dealing with these micro coax connectors. And in this particular case, the K.FL2 kind of falls in between, say, U.FL and an X.FL. If you have a customer that's dealing with really small wearable products, really small stuff, they might want the smaller size of an X.FL. But if you have customers that are downsizing their product from traditional Wi-Fi and Bluetooth connectivity that uses U.FL, they may need a little bit of space savings. And we've been starting to see this size class of product in the market more and more on Wi-Fi radios. And one of the big contributing reasons for that is that when you look at a modern Wi-Fi or application, and usually it's blended Wi-Fi and Bluetooth, but just Wi-Fi alone requires a lot more antennas for compliance with Wi-Fi 6, 6E, and 7. Those are the more recent standards for Wi-Fi technology. And as a result, more antennas means more connections, and that's good for us because you have the opportunity to sell more connections. But for our customer, there's a real estate challenge there because they have to get more of these connection points into a tighter space. So bear in mind, customers that are going into that Wi-Fi 6, 6E, or 7 range, chances are they're going to be looking at potential for downsizing. So if you have existing customers that are working in Bluetooth and Wi-Fi, those are great customers to show this K.FL2 type series product, especially if you know that size or space available in their system is a challenge. So we're going to dive a little bit into the specifications, but the first thing I really want to highlight on this slide here is talking about the VSWR and the frequency range. When we're talking about Wi-Fi 6 and 6E, bear in mind the frequency range has risen in the market for this type of stuff. And we're now talking about frequency ranges north of 7 gigahertz. And with traditional connectors in the past, the ratings are really around 5 or 6 gigahertz. And we typically see in some of our competition out in the market where their performance significantly gets worse as you pass through that 5.5 gigahertz range. And Hirose, and I'll show you in a little bit later slide here, we've been very stable in the performance on our connectors. You can see it kind of in the bullets here, where we're holding that performance nice and steady through the wide range of frequencies. So let's go ahead and jump in and talk about some of the other cool features on this product series. So first thing I want to point out is that this series is available in 2 different styles on the plug side. So you got the receptacle side, you're all very familiar with, it goes on the PC board. And then traditionally you have the cable plug, goes on the end of a micro coax cable and attaches on the end there. And Hirose sells this as a cable assembly. So bear that in mind. We're not selling the tool. We're not selling the crimp-on plug that they are doing the termination on their own. We are selling this as a cable assembly. So when you're working with the customer, make sure you're talking about the cable assembly side of it. Sometimes we focus on the PC board side of it, but bear in mind the cable assembly is just as important. Actually, honestly, the cable assembly is actually more important than the receptacle on the board. The performance losses that occur most often happen in the cable assembly, not in the receptacle on the board. So you want to bear that in mind when you're talking to a customer. Don't just focus on the PC board side. Talk about the cable assembly side and make sure that your customer is adding to their bill of material the specification for the Hirose K.FL2, both on the receptacle and the cable side of this. The other thing I want to point out on this series, you can see in the pictures here, is we do offer this in a FPC mount design. FPC really here, what we're gaining is the ability, some customers are using FPC-based antennas, and they may be looking for a way to attach. Traditional method with a more rigid style of antenna is that they take a cable assembly, maybe it's double-ended, they cut it in half, turn it into basically a pigtail, and they solder one end to their antenna, and the plug side plugs into their piece of equipment or the radio on the PC board. With FPC, it's possible that they could have an FPC-based antenna, and they need an FPC mount plug to plug into that receptacle on the board. So that FPC mount plug saves them the effort of having to solder a cable to the face of the FPC. So this is a big advantage during manufacturing for them, hopefully reduce their cost in their situation because the FPC processing is going to be conducive. Instead of trying to hand solder this thing, they can work with a reflow type connector. So this is a big advantage for a customer. Other thing I want to point out on this slide is the height difference here. So 1.2 millimeter stack height on a cable assembly. FPC a little bit shorter here. Primarily what you're saving here is the thickness of the coax. Bear in mind, you are going to FPC, so the FPC thickness is defined really by the customer on their setup. So depending on how thick they make their FPC, but the interface itself to the bottom side or the surface mount portion of the FPC is 0.9 millimeters, 1.2 millimeters on the cable side design. So when you're working with customers, if they're looking at FPC, they might have a nice smooth flat surface, or they got the FPC antenna. It's not adding any significant bulk to go to this design. Slide to advance. There it goes. Awesome. So another big thing, Hirose is well known with our FL series products for our very clear tactile click feeling to the connectors. This is still true on the K.FL2 size, even though the connector is getting smaller. We do still offer a very distinct tactile click and feel to the connector. So as they're mating it, they know that they're getting it mated properly and reliably. This can be a big concern in manufacturing. I'll tell you, in the field, when I look at installation applications, improper mating can cause challenges. Connector doesn't get fully mated. It might come out later on during shipping or while the customer is using the product in a future date. Remember, many of these type things are in consumer electronics, so consumers can be a little rough on their products on occasion. So that might cause unmating, and hence having a nice, distinct, clear tactile fit to the connector allows the manufacturing side to know that they properly connected the cable to the PC board. So that's a big advantage to our design here. And you kind of can see we've designed the connector to really handle that and mate, and has a nice distinct feel to it. As it comes together, we've really engineered into the connector housing, really in the plug housing side of it, some skills in that area that we have on all of our FL series products. So that's a big advantage for Hirose. So let's talk briefly about the, actually, let me just jump for Scott to the our first question on this product area, and that is, what is the mated stack height on the K.FL2 cable assembly version between the with the PC board? All right, I'm going to go ahead and move on to the next slide here. And we'll talk a little bit more about that tactile, robust feel of the connector. Hirose does spend a lot of time engineering the plugs so that they are durable. And we certainly do see complaints in the market about durability on connectors in this size class. And this is a great opportunity to point out to your customer, say, hey, are you using, I see that you might be using the Hirose receptacle on the board, but are you using the Hirose cable assembly? And that is honestly where a lot of that robustness comes into our design. We are designing to have the C-shaped ring around the collar of the connector. This gives it structural integrity, ensures that mating reliability. We do have excellent retention performance on this, but I want to point one thing out regarding retention. This connector is smaller than a UFL, and I know we spend a lot of time talking UFL-A and the really, really high retention on that. As the connectors get smaller, you do lose some of that because the connector is physically smaller. But Hirose has done a great job of maintaining excellent retention forces on this. We are better than our competition. I know earlier somebody asked about who's your typical competitor in this type product. IPEX is a big player in this market, and it'd be their MHF4 series. And that would be our competition in this realm. We are better than them on both the electrical performance and on the retention force values. So we are improved. So if you have a customer that's using their product today, this might be a great product to get into their application, especially focus on that cable assembly side to help them as a total solution, not just the board mount side. I know that's the easiest thing to hit right at the beginning, but do focus on getting the cable assembly side of it as well into that design. And let's take a quick look at the mounting side of this. On the PC board side, you can see the shape and style, very similar to what you've seen in other FL series products. We got the nice gold plating. You got the nickel barrier in there. That nickel barrier is very important because solder from wicking up into that center pin. Not everybody does it this way. Hirose is really good at our receptacle designs. We are very popular with many of our product series in these FL products. And when you're talking about that manufacturing side of the process, sometimes if folks are struggling in that realm, then we'll see is that it may be because they don't have that solder wicking prevention. So this is a big plus for us. Somebody was just, I think, asking about frequency performance on this stuff. I thought I saw a question on it, but now I'm not seeing it in the chat box. But we certainly do have excellent performance within this connector. There is a difference between the Flex version and a coax. And one thing to note about coax versus FPC, right? At the end of the day, the FPC is more challenging with regards. I mean, coax just plain is really solid for performance. So the performance on the coax style is going to be better than it is on an FPC. But FPC does have advantages based on the design and requirements within the scope of the customer's product. One of which, as I mentioned, FPC-based antennas. It may be based on how they are laying it out on their boards, or bear in mind if they have some kind of interface that they need a daughter board going board to board. That's another possibility using the FPC-based style of connector, because that is board mount, so you can do that. Just bear in mind, small connector, so it's not typically used in those type of applications. Usually it's FPC-based in those situations. So we certainly do see a performance difference between these two. So jumping back to that conversation, I'm talking about FPC, that's where my next question that I have on this. And by the way, I did notice in the comments box, someone mentioned they had trouble submitting a vote. If you are having trouble submitting a vote on one of these questions, just put your name in the box and put your vote right after that. And I do look at those. That, if you want to do it that way, you still qualify for our contest. So when you do that, just make sure you put your name with it. But what is the mated stack height on the K.FL2 when it's the FPC version interface to the PC board? So that's our poll questions. Bear with Scott's having a little bit of trouble getting these posts to pop up. So if you haven't seen it pop up, just give it a moment here. Scott, were you able to post that?
It seemed to post but it's not letting us vote.
Yeah, all of a sudden the network slowed way down for me too. So not too sure that's a us problem. That sounds like a Microsoft issue.
Oh, there we go.
There it goes. Finally, that is weird. Sorry about that. Slaves to technology. They just need better connectors back in their server farm someplace,
Yes.
right? Isn't that how it's, whose account is that, right? Maybe if they were using the Hirose K.FL2, they'd have better Wi-Fi connectivity in that device, right? Awesome. So we'll get some votes in there. Like I said, if you're having trouble doing the vote, go ahead and just put your name in the chat box, put you at the, A, B, C, or D in there, or put the value itself if that's easiest to make sure. And I do look at all that stuff later. That's awesome if you can do that. All right, I'm going to talk a little bit about some of these applications. I know I kind of dribbled applications in all through this process. Obviously, as we're talking about connectivity getting smaller, we're usually talking about portable devices. Wearables are probably going to be looking for the X.FL, which is definitely smaller. But you can still see this in tablet devices and PC devices. Look for things like small office, home office, Wi-Fi, routers, that type of equipment. The other market I wanted to point out that's not on this slide, and I wanted to do certainly do a mention on, is the medical market.
One of the first places I saw this size connector show up was actually in a medical device. This was a testing piece of equipment used in operating rooms, and it actually had, and it wasn't like it was a typical Wi-Fi 6, 7, or 7, type of device where you have 12 antennas. It was actually only 2 antennas. It was running older technology, but they needed to downsize the product. One of the places they saved on real estate was in the radio module by using smaller coax connectors. So that's something to bear in mind. It's not just consumer products. Look to markets that are using Wi-Fi, especially Wi-Fi 6, 6E, and 7, because that's where we're typically seeing that downside need, mostly because the number of antennas are increasing. But that could be medical. That could be other industrial type environments where they are using modern Wi-Fi technology to allow more connections, wider bandwidth, and more devices in general. So that's great markets for this type of product. So not just consumer, but medical and industrial. Highlight especially on medical, because they are going to be looking to push those Wi-Fi performance levels in the future. So is the end on the K.FL2. The next product series I wanted to bring up is our FH82 series, which is part of our One Action family. And the One Action family, we talk about this a lot. We have quite a few products, our FH63, our FH67, FH72, FH62, and now the FH82. Now, I was talking to product team, and this product's actually been out for a little while now, and you may not have seen it too many places advertised. And what we wanted to stress is right now, we did get this released a little bit more publicly, so this is why we are talking about it today. But we are asking that you target your customers at selling whole real increments and not fractional quantity. So when you're working with customers, look for whole real increments when you're doing the sales on this. It is a very small connector, and that is one of the big advantages of this thing. We're talking about a 0.25 millimeter pitch. But the other big thing here is the height off the PC board at 0.65 millimeters. And Hirose is really well known for our small connectors, and this is certainly within that category. This is One Action. If you have a customer that's using lift connectors today, One Action works almost like a lift, except that it actually latches in place. So you just insert the flex in and it stays, and it self-locks. It's like auto locking feature. And this is a big advantage for customers, especially customers that are working in tight spaces. So let's take a little bit closer look at some of those. Get my slide to advance. There we go. Now you can see kind of the dimensions. So the 14-pin example here we have is 7.2 millimeters wide. And a lot of that comes out of that 0.25 millimeter pitch, right? When you go to a smaller pitch, you do gain the benefit of space. But another thing that I want to mention with this product series is if you look at the image on the right-hand side, notice that the contacts are what we call a double-sided lead design. So although the connector is using 0.25 millimeter pitch flex FPC, the mounting pitch on the PC board is 0.5 millimeters. So this is actually a really cool thing to highlight with your customers. Many companies will shy away from using 0.25 millimeter pitch, even though they need the space savings, simply because the cost to manufacture a 0.25 millimeter pitch PC board is higher than the cost to manufacture a 0.5 millimeter pitch PC board. The only thing that has to be 0.25 is the FPC that goes into it. There are certainly FPC manufacturers that can handle that out there. We do have on our partners page. You can see partner information if you are looking for an option in that realm. Our partner that we have listed can certainly handle the 0.25 pitch with no issues at all. So the size on this is the big key advantage for this product. Let's take a little bit tighter look at the design here. When we're talking about One Action design, as you can see in the diagram here, you just insert the flex. You do not have to work with the actuator during the assembly process or insertion process. And those actuators do ship in a closed position for the shipping process, so they don't have to operate them or do anything to prepare the connector. Goes onto the board, and then when they go to put the flex in, they just insert it in and it locks into place. And you can kind of see the diagram on the edge of this thing where we have the kind of latch that grabs onto the tab on the side of the FPC cable, and it grips in place. That's all done internally. There's nothing the customer has to do. It happens internally on this product design. So, and then when we're talking about the removal side of it, they just open up the flex on this. You open up the actuator on the back side, that pops open, and that allows the FPC to pull right back out. They can reset that actuator back down, and it's back to being a one action series. So they only have to deal with the actuator if they have to remove the flex out of it. So I'm going to jump into my first question, or my question number 3, which is first question for the FH82 series. And I've said this several times, so you should see 100% answers on this one. What is the pitch of the FH82 series connector? Okay, see some bunch of responses. Seems like everybody agrees with everybody. All right, you're all wrong. To be found out at a later date. One thing I do want to highlight on this thing is Hirose, well known for the retention forces on our flex connectors. We certainly continued that. As small as this thing is, we see that comparing to a traditional connector in this type of size class, nearly double the retention force. And this is not just us looking at our own connectors, but also out into the field. That one action functionality really helps with these small connectors. So this is a big advantage. Again, looking at that 14 position size to make that determination for that retention. Retention force is a big deal. Another big thing for us in this type of product is that you can use this for visual confirmation during manufacturing. When you're working with customers that are working with really tiny connectors, machine vision imaging is often used in the quality control systems, quality assurance systems, to make sure that flex is inserted properly and everything is set up properly. So we have designed this product around the idea you can take a look at the corner edge of this thing and you can visually identify whether your flex is properly inserted. This is a big advantage for customers, especially in the consumer electronics market, simply because of the volume that we see in those markets. It's just more practical to have something be a visual machine inspection than to have to worry about an operator pulling on something to determine. Now, I don't know if I am maybe repeating myself here, but looking back, we do have a distinct feel. When you put this in, you do get a distinct feel that it is latched in place. You know, it's not just like a sound so much as you do feel it. And when you talk about high volume production facilities, some folks would say, wow, the sound's a great concept, but I really need to feel it. And yeah, that's the case with a product like this. You are going to feel it latch in, has a nice distinct feel as it comes together, but you still have that backup option of using machine vision to be able to see the inside of this connector. So my next and final question that I'm going to ask on this FH82 series, one action series product. The FH82 one action series ships with the actuator already open to speed up manufacturing. True or false? Lots of answers rolling in. Just going to scroll up through the list here and see if I missed any questions that popped in. Don't forget, you can put questions into the chat box as we're going. I do have it open on my screen, so if I see something pop in, I'll try to answer it as I go. Right, some nice responses there. Thank you, everybody, for participating in our poll questions this week. I'm going to go on to our next slide here and talk a little bit about the internal structure of this product. When we're looking at these really small connectors, one of the big concerns folks will have is dust getting inside, or maybe it's on the flex as they're inserting this thing. This is a wiping style contact. So as it comes in, you are going to get a little bit of a wipe on that contact. This means that it'll keep some dust off those contacts, so it ensures excellent quality electrical contact between your FPC and the connector. So a wiping contact is just a big advantage. This is especially true with small pitch connectors. So when you're working with a customer, if they're concerned about that, or maybe they had a bad experience in the past with what I'll call a conventional or traditional type ZIF connector in a small size, this is a wiping style contact, and that is a big plus. Another thing when we're talking about small connectors is solder wicking. And I mentioned this with the K.FL2, and the same is true here. Hirose does spend a lot of time and energy to really focus on preventing solder from wicking up the contact into the internal structure of the connector. This is also true with the FH82 series. We've designed this so there's no gaps between the housing and the contact. This means that the solder will not wick up into the housing. Small connectors, this can be a big problem. So we've certainly taken care of and alleviated that concern for our customers in the manufacturing. So Hirose not only focuses on the design and engineering of the connector for the electrical performance and for the physical size and all those features, but we also try to take care of those on the production line to ensure that they're not having issues just because the engineer picked out a really cool connector and it goes to production and causes headaches for the production team. Hirose thinks about the whole process end to end to make sure that we're providing a solution that's not going to cause some headaches. So that's a big advantage. I've mentioned throughout the presentations talking about the types of projects that this stuff is used in. We are still talking mostly in that consumer electronics market space, but I want to point out once again, medical devices is a great market for these types of products. Medical devices are getting smaller. When you go into the hospital, into an exam room, they're doing ultrasounds that are using tablet-style devices. They're sending consumers home, patients home with medical monitoring devices that are fairly small. These devices use smaller connectors. They're tight spaces. They need that low height. Remember that 0.65 height off the PC board? They need that smaller size to make it work. So this is a big advantage for those type customers. So that's the wearable side, but think medical wearables, not just wristwatches, right? Where, medical wearables is a big area. Another cool thing, I was just watching a video just recently that I think Scott put together showing an application in a warehouse where they had a barcode scanner that was wrist mounted and it's used in a warehouse to do barcode reading. We see stuff like that out in the market. If you have industrial barcode scanning type customers, folks that are building industrial scanners, readers, camera systems, machine vision systems. I mentioned you can use machine vision to identify the connector. Well, maybe they could use this in the machine vision equipment. So if you have folks in that industrial market, that's a great place to look at it. So consumer electronics are making their way into applications that are traditionally considered industrial. And that because of that small size and those screens and displays and all the bells and whistles and data capture and all this stuff is happening, and we see that, but they need the smaller connectors. So if you're showing, man, Dave, I don't have any consumer electronics customers, that's okay. You probably have medical, you probably have industrial customers. So do present these smaller connectors to those customers and you will see success. Highlight that 0.25 FPC and that 0.5 millimeter mounting, because those industrial folks, they don't like 0.25 on the PC board. They're going to be looking for staying north of 0.4, and this product is 0.5 for the mounting. Huge advantage for your customers in manufacturing. So appreciate your time today and all the answers. I think there was some additional information about competitive at TAC. Thank you very much for putting that into the chat box. Everybody, if you check out the chat box, you'll see a response on that competitive question that came in earlier from one of our excellent product management team members is in there. So any additional questions?